guys tell? Oh, it froze again. Can you guys tell where these questions came from? Were they like review pre-cal, or was it like, no, this is section 1.2 stuff? Yeah, section 1.2. Number 77. Let's see, group number. I have no idea what groups I used last week, but that's okay. We'll just start over again. Group number 2. How could you write this problem before even solving it? Translate it.
X as x approaches pi.
Do you guys agree?
Yeah.
The limit as x approaches pi, that's what they said, of h of x equals x, so it's just of x. And kiddos, what do? We can kind of cheat just a little bit using what we know of solving. What's the answer? Plug it in, plug it in. So we all got at least one right? Questions on that one? It's a mood, isn't it? It's a good skit. Number 78, or YouTube video. It's a Monday. The function f of x equals, okay, we already talked about this one, right? So I'm going to go ahead and write it, because you guys technically already kind of gave it away. The limit as x approaches 0 of 10 over x to the 4th. You had the graph even to help you. Group number 4, what would you say the limit is then? How come? Yeah, it gets closer and closer to 0 and doesn't touch it. And Katrina, where are the heights going? And so why would, in this section, before we've technically learned any better, why would the book everybody say non-existent? It's not one single constant. It's infinity. Yeah, it's infinity. Now, will the AP answer infinity? Yes. However, we're just kind of getting going. Non-existent is the exact same thing as the limit does not exist. True? Number 79. What is the limit of f of x as x approaches 0? I'm going to go ahead and just write it because I'm thinking at this point we kind of know what's going on. They're just giving it to us verbally. X approaches 0 of e to the 3x minus e to the x all over x. Group number 6. What do you think? D. How come? What happens when you plug in? 0. Now, they're thinking it's non-existent because 0 over 0 isn't an answer, and that's true. 0 over 0 is not an answer, but hold on, last year, and I know this is kind of like peeking into 1.3 just a little bit. Question. What do we do with the 0 over 0?
Keep going.
How do you keep going? Divide the top and the bottom by what? Simplify? How?
Got rid of the e's.
Okay. We could pull out an e to the x, and what do we end up with?
E to the 2x minus 1.
This is actually one algebraically you guys couldn't do yet. However, in section 1.2, what did we learn to use? Let me do a timeout real quick. You guys, in your calculators, put in the function. You can either look at the graph or you can look at the table. Automatic. Not automatic. Ask. See if there is an answer, even if we haven't learned L'Hopital's. I mean, the thing that we're going to learn later as to how to solve. Wow, this is section 1.2. These are hard questions for 1.2. But that's okay, because you learned how to use your grapher. How many of you guys used your grapher already? The rest of us didn't, so.
Okay, so I do the table. I do this thing. Oh, good point.
Does that make sense?
Yeah.
What are you guys seeing? The answer is?
D. D.
I think so.
e 3x minus e to the x. We just take out the e and then 3x minus x, and we take out the x. Yeah.
Very creative, but that's not going to work again. E for F. E for F. Once we learn how to take a derivative, there's this nifty rule that says you take the derivative of the top and the bottom and then do a limit, which means the limit of x, or the derivative of x would be 1, derivative of this is going to be blah, 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 ends up being 2. But that's the only other way I know of, Lauren, to solve that one. Number 80. All right, he was a bit of a mess. And we have no group number 8. Now it's going on the even groups today. So let's work together on this one. Ugh, what kind of function do we have? Piecewise. Well, that stinks. What limits are they taking? The limit as x approaches 3. Now hold on. They don't deal with the piecewise yet. And actually, let me scroll up just a little bit. They don't deal with the piecewise yet. Oh, that's what I want. Instead, they just deal with the square root of x minus 2. Question, what is the limit as x approaches 3 of the square root of x minus 2? Yeah, that's right. That's right. Now, if it was approaching 2, we'd be in some trouble. But no, this is totally fine. That's good. How about the next one? The limit as x approaches 3 of 6 minus 2x. What's that? What are you guys doing to solve those and say that? Your calculator? You're using the cheater trick of plug it in. So what about Roman numeral 3? True or false? The limit does not exist as x approaches 3 of my piecewise. True or false? X minus 2 square rooted is, that shifted 2 to the right, right? Square root of x. According to my piecewise, does it hit at 3? No. But it goes all the way up. Square root of x minus 2 is the path of the driver on the, greater than, my bad. I thought it was less than. The path of the driver on the right. Ish. What's 6 minus 2x? The path of the driver on the right. Question. Why did these force me to say the limit does not exist is true?
They don't agree.
As each comes towards 3, they're going to 2 very different heights. One function going to 2 different heights at one x value. Is that a problem? He is not true. No. The limit does not exist, which means he is true. The limit does not exist, which means he is true. Therefore, the final answer is 2. If you guys need to make any corrections, do so in the next 30 seconds, because this is leaving. It'll be online. If you guys noticed, I was taping that whole time. Now, we're going to need to cut these down so the warm-ups don't take as much time. However, the nice thing is, how much time are we taking on section 1.3? 2 days. How come? He's everything limits algebraically. He's everything limits algebraically. Limits analytically, I think is technically how it goes. We're going to go ahead and get into section 1.3. You guys have your spirals with your homework. We're going to check the evens, but go ahead and get your composition books out and ready. Get set up. Composition books ready. Colored pen with homework ready. And let you guys get your notes set up, table of contents updated, etc. We're still trying to get used to that. I don't think we had too many evens in homework, but we will quickly grade those. We won't go over any odd questions today. However, that doesn't mean that you can't come in later and ask me on any odds that you have questions on. Just remember that's what math class is for. Some of you guys are already doing it. What do I mean by that? You're already solving limits this way, some of you. Hopefully, most of you, because you were doing it this summer for the summer packet. Make sure all my microphones are all plugged in. So, what you guys hopefully already started writing when you came in today. Wait! Why is the limit as x approaches c of b still b? Don't you plug it in, plug it in? B is a constant. So, example down below, the limit as x approaches 2 of 3 is, well, 3 is always 3, so it doesn't really matter. What's the value? 3. There is no x to plug into. Does that make sense? There is no x to plug into. This mouse is in the way. Hold on. The second property says, now if I have an x, the limit as x approaches c of just x is, now am I allowed to plug it in, plug it in? Yes. So I can just say -4. And then letter C says, if I have any single x to any certain power, oh, I have these? Look at this. Compared. Remember next one. What do I do for x squared or x to any power? Plug it in, plug it in. Oh, that's easy. 2 squared, right? Because as x approaches 2, which equals, how hard are those? That's where our book starts off. They even have a theorem about it. But we got this, right? Now there is another theorem that's a whole lot longer than this one. But I don't want you guys to write it down. Let me double check it on the next page, I think. Oh yeah, I think it is. But these ones, the limit of any constant is the constant. The limit as x approaches any number, any real number of x, just the number itself. And the limit as x approaches any real number of x squared, plug it in, plug it in. Now, question, what could make these get harder? More stuff, right? Like, now don't write down theorem 1.2. It's an important theorem. I just want you guys to kind of be looking at it. Don't write it down, don't write it down. You don't need to memorize it. It's not a forever card, nothing like that. Okay? But what's it saying? We're dealing now with separate pieces, which f plus g could just be a polynomial. It could be x squared plus 5x or something like that. Okay? So now I have terms that are being added, terms that are being multiplied, terms that are being multiplied by a scalar or a constant. Learned about scalar last year, right? Non-dimensional. I cannot say the right words these days. A non-dimensional number. Blah, 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 blah. We're going to be dividing some stuff, raising some stuff to a power. Now, what do these properties allow us to do? Don't write them down, but write down this example. Okay? Don't write this whole table down, but let's write this example. A lot of you guys know what to do on this one, but I'm just showing you why we're allowed to. A lot of you guys know what to do. I'm just showing you why we're allowed to. According to the properties up above, the way technically we would need to solve this, like in order to show each of these properties being applied, would be first of all to say, hey, stuff's being added. Well, those things that are being added, I can split up and take the limits individually, like the limit as x approaches 2 of x squared plus the limit as x approaches 2 of 5x plus the limit as x approaches 2 of 4. The property allows me to do that, to split them up and say, hey, I can get the limit of each piece, because each of those capital letters stands for the limit of each piece. Now, I can go even one step further and say, that's the property from the page before. The limit of any constant is the constant. Why did the limit disappear? Because I took it. The limit as x approaches any constant of x to any power is, plug it in, whatever x is approaching raised to that power. However, I don't have a property on the page before for this one, but I do have one up here. I can pull that 5 out and take the limit as x approaches 2 of x, and that's a property from the page before, which said the limit as x approaches any constant, any real number of x, plug it in, the operation is multiplication, And now I can go ahead and simplify. PEMDAS, do the exponents. 4 plus 5 times 2 is 10, plus 4 is 18. Now, I want you guys to do this every time. No. Please. It'd be agonizing for you and for me to have to look at. No. What's the long story short? The properties of limits say, basically, as long as it works, what can we do with any polynomial? Split it up, but basically just plug it in, right? Plug it in. Let's keep going. So that's why I didn't want you to write down that whole table. It actually is important in letting us have our cool plug it in trick. But we're not going to do it. That's too long. Okay. So hold on. Let's zoom in. What's showing on the ceiling? All of that is. You see that a little better? Okay. You guys start writing. I just want you to leave me one line. One line for every single one of these. Basically, our book took, oh man, how many pages did our book take on this? 1, 2, 3. I guess just 3 pages, but 1, 2, 3, 4 different theorems, and I'm kind of summarizing it in one short, sweet page. Okay. Not making us write the theorems down. We're just going to do the short and sweet of it, the long story short of it. Just get me one line in between each. And don't worry, once again, this isn't something to memorize, just something to be able to reference when you see some tricky limits, okay? This is supposed to be let out and it has to be loud, isn't it? Tomorrow's basically going to be a day full of examples and full of the funny stuff, like rationalizing stuff with square roots by multiplying by the conjugate, simplifying complex fractions. Dealing with trig, dealing with ln, dealing with e to the power of, and all sorts of funny stuff. Dealing with piecewise functions. Ugh. Let's just quickly remind ourselves for each of these different types, and this is basically all the different types of functions that you're going to see in this section, and to be honest, for most of the year. Polynomial. The limit as x approaches c of p of x just means polynomial of x. It could be a quadratic or a cubic or a quartic or who knows what. Just plug it in for c being a real number. And kiddos, have you guys seen the limit as x approaches any imaginary number yet? And you're not going to. So hey, polynomials are always good. Just plug it in. No big deal. Rationals, aka a function with a fraction of functions. Could be 5 over x, could be x plus 1 over x squared minus 7. Who knows? All you have to do is plug it into the numerator, plug it into the denominator, and simplify. But question, when could that be a problem? 0 on top isn't a problem if it's only a 0 on top. But if the bottom equals 0, and there's a couple different ways that can happen. We'll talk about tomorrow indeterminate form versus infinite form. It's totally fine to plug it in as long as it doesn't make the denominator 0. If it does, we'll have to do something else. Radicals. We have 2 different cases. N is odd. Wait, who's N? Can you guys see him? He's kind of small. N is the index of the root. Square root would be, well, it would be there. Cubed root, they have a 3, a 4th root. If N is odd, we can say for all C. If N is even, because odd roots go on forever, have a domain of all real numbers. For even roots, for all c greater than 0. Meaning for all arguments greater than 0. Wait a minute, hold on. Square root of 0 is 0. Why can't it be greater than or equal to 0? We'll look at that tomorrow. For all composite functions, f of g of x, we can just take the limit of the inside. Bless you. Take the limit of the inside and then plug it into the outside. And I'm just going to say within the domain. Within the domain of f and then of g. Trig! It's fine all the time as long as it's within its domain. I think I see a pattern here. Exponential and logarithmic. It's totally fine just to plug it in, and solve within. What am I going to say? Yep. So the only time funny stuff's going to happen is when I have fractions, when I have radicals, when I have ln's, or trig with vertical asymptotes, or piecewise. And those are the troublemakers that we're going to go ahead and basically get nailed down tomorrow, okay? Kiddos, I'm letting you out. I'm sorry it was 55 seconds late. But pause 1 second. How many of you guys were able to do a lot of that warm-up using plugging in techniques today? You can start homework. But worst comes to worst, make sure you finish your favorite online tutor by midnight. I'll see you guys later. Homework's not due till Wednesday.
Tutoring.